It gives me great pleasure to introduce Jim Small. He's our presenter tonight on IPv6. Take it away, Jim.
All right, thank you, Jim.
Launched 2015, January.
All right, welcome. So I wanted to start with a brief introduction. I got really kind of interested in IPv6 in around 2008, and I started putting serious time into it in 2010. And looking back, if I would have known that we'd only be where we're at right now, I don't know if I would have spent as much time as I did in 2010. So it kind of brings me to the topic of this presentation, which is IPv6 is an interesting challenge because I think everybody, most people that have spent any time with it know that it's necessary, but it's one of those things, it's so basic, it's like a platform that it's hard to figure out how do you think of it. Where does it fit? I think a lot of things today are thought of as products, right? I buy a product, I buy a solution, it does X, I figure out how to integrate it to my infrastructure and away I go. And that totally doesn't work for this. This is more like a platform, more like something like Java or Cloud or something like that. And it's a little strange because since it's a platform, it's really plumbing, it's infrastructure. There's no immediate benefit. So I think that's why we're kind of, we're making progress, but we're stuck a little in terms of, if I'm looking at my company or my business, or I'm looking at opportunities, I'm thinking, okay, if I'm gonna put time into something, what's the payoff? What's the benefit? What do I get, right? And if it's something like infrastructure, almost like electricity or water or HVAC, I mean, that's typically not in the purview of IT, right? That's not the kind of thing I worry about. And actually, those are the areas where IPv6 is coming. So that makes this guy interesting. And when I was thinking about this, I've been giving these talks since, lots of talks since 2011. And like I said, we've made some progress, but it's been pretty slow. And really the challenge with IPv6, I mentioned this to Jim a little, it's not so much a technical problem, because if you look on the internet, I mean, there's lots of books. I mean, pick your favorite vendor, pick your favorite product. I mean, there's whole books on how to configure it, how to do it. We'll go through a little of that, but that's not really the problem. The problem is why? Why would I want to do this, right? How many people have less than 10 priorities they're looking at right now in terms of like technologies they want to do, products, to-do lists, whatever, right? So I mean, this is just not high on the list, right? I mean, it's kind of interesting, maybe like DNSSEC. We should do it. It's kind of nice, but question?
There's also another problem in that, like my provider still doesn't have me hooked with IPv6 even if I wanted to.
Which was your provider?
AT&T Uverse.
Really? I thought you might have to do it manually, but you should be able to get 6RD.
Well, maybe it's my gateway that they supplied with.
That's possible. That's possible. It should be possible, but maybe we can talk to you a little about that.
Well, you're an architect, so you can go fix it for him.
Oh boy, yeah. Well, even my influence is pretty limited there. So I guess when I'm looking at this, and I try to think of how can I make this interesting, or how can I provide an interesting story or context for where IPv6 is at. And so what I came up with was the matrix, because if you look at TCP/IP, it's so fundamental. I mean, it's so basic and ingrained in everything we do every day. I mean, our phones, our computer, our world, right? I mean, can you imagine if I told you that we're yanking out IP and we're putting in a new protocol, and how long would it take you to get everything up and running at home or in your company? I mean, it'd be years, maybe decades, right? So, when we're talking about messing with that, it's scary, it's frightening, it's just, it's like changing your language, right? You just don't want to do it unless you absolutely have to. All right, so the challenge that we have with IPv6 is, again, with TCP/IP, You know, there are some, I know there's some of us in here that have, that actually predate TCP/IP. Predate the IP internet, right? There's a few of us, but there aren't many, right? Most people in the industry today have basically grown up with TCP/IP, and that's all there is. And I can tell you that when I taught networking for a long time in college, and people would usually be really confident until we talked about a non-IP protocol like DECnet or ISIS or IPX, and then they really had trouble because they're like, well, that's not networking, right? Because everything is IP. So it's hard to see outside of that. And the challenge is, we have two things, right? So whenever we transition from one technology to another, we have to have some kind of a bridge, right? So how do we migrate? And so in order to do that, we have solutions to help with the migration, you know, gateways, translation, proxies, things like that. The problem is, the more we extend things, and the more we come up with all these gateways and things like that, it's almost like we're creating a disincentive for people to migrate, right? Because I don't really have to migrate, I'm gonna get this proxy or this gateway, and we just build up all this inertia. So it makes it harder. And then what we've reached today is, and I don't think we're gonna be stuck there forever, but we are going kind of slow, is we've reached this impasse where most people still don't want to make the switch. So at the same time, we basically have a protocol that was not designed for a global internet. And so it's totally stretched. And so in order to survive, now we have to do what's called CGN, or cascading NAT. And we keep rolling out more and more of that. And we've kind of created this illusion where I talk to some of my friends that do this, and they're like, well, you know, my customer's gonna look at IPv6 in 10 years. Which I'll tell you right now. so let me say something else too. So you guys aren't paying me, right? So I'm gonna be pretty frank. So I hope nobody's easily offended, because I'm not gonna feed it to you gently. So 10 years is a pipe dream. Okay, IPv4 doesn't have that kind of lifespan left in it to support the kind of demands we're putting on it. However, because we've done such a good job at extending it, we've created this illusion that everybody is convinced that, you know, yeah, I should do IPv6, but I'm going to do it next year. I'm going to do it in 5 years. I'm going to do it in 10 years. You know, I'm going to come back to it. So I want to talk a little bit about this and what I see missing. So I go to a lot of conferences. I talk to a lot of people. I work with a lot of people. You know, I've seen and done hundreds of technical presentations, right? So again, I mean, if you guys are looking for technical content, there's tons of stuff. I mean, if there's something specific you're looking for, ask me, I point you in the right direction. Tons of free material, right? So this is not a technical problem. Really, to me, and this goes back to kind of being a teacher and a consultant, I think the problem here is we're not looking at the fundamentals. I want to take a little time and talk about, you know, what's the problem, right? I mean, can somebody tell me what's the problem with IPv4? Why would we migrate away from it?
Number of addresses available.
Number of addresses, right?
Yeah. Most of the workarounds are all to, you know, we used to have one IP per website. Now we've, you know, using DNS with Apache, you can have multiple on there. We've solved the SSL problem with it, but like you said, it's a patchwork to try and figure out how we can fix something versus moving over to IPv6, which would solve the problem, where you could just one-to-one all the different sites and computers and networks.
So I don't want to get stuck on this too much, but you know, if I'm going to play skeptic, I would say, well, we've had NAT forever. We have PBXs. Why can't we just use PBX-like systems? What's the problem with that? Why do we need unique addressing? Why is that a bit? Who cares? What's the value? See, that's the problem. Can anybody give me a good answer?
Directly connectable.
Yeah, as I said, you can't directly connect to.
That's true, but you can get around it, right? See, this is the issue. Is I don't think there are good answers to that question. So I want to kind of step back a little, So I hope you guys like this, and I hope this is valuable. I want to kind of step back a little and talk about what is the value of an addressing system? Because this is kind of looking at something like the grid. You know, why do we need the grid? You just don't think about it, right? I mean, it's just a given. But I think in order to make this transition, we have to look a little at these details and figure out how are they useful. So if you look at the purpose of an addressing system, these are the main goals that it's trying to serve. So uniqueness, right? The idea is that everything should be addressable. I should be able to uniquely identify all the nodes on my network. We'll come back to why that's useful later on. Topology, right? In fact, a lot of people would argue that it's a mistake to have identity and topology overloaded into the same semantic construct. So there's a lot of things like lists that are whole interesting other talks that, you know, to try and split that up to make things more modular. But for now, typically addressing systems combine both of those. Registration, right? If I have to find the person who owns this, how do I look them up? You know, for troubleshooting, things like that. Routability, which means can I reach them? How do I get to them? And finally, and this is a big one that we've really lost sight of, is operational simplicity. So one thing that everybody agrees on, that's you know, everybody keeps talking about, is in the next 5 to 10 years, we're going to have orders of magnitude and increases of the node count. So how many people think they're going to get an order of magnitude more staff to support those devices? Nobody, right? So then we've got to make sure that it's operationally simple, right? If it's complicated, then it's going to be hard to manage. All right, so I'm not going to belabor this. I think this is a good reference thing. But if I look at IPv4, this drives me nuts. Okay, I'm an engineer. I'm kind of anal. So it drives me nuts when I see all different kinds of numbers. So if we look at IPv4, and I'll skip this just to save time, but the bottom line is usable address space, we have about 3.7 billion. So if anybody's curious why, that's all the detail, all the relevant RFCs. This is a hyperlink that goes over the IANA special purpose addresses if you're curious, because that does change from time to time. But that's it. So that's because I every day I see a different number, but that's the actual number. So if I look at this, how do I figure out what's on the internet? So there's a couple different ways. One way is I can look in DNS. I can say, what are all the FQDNs in DNS? And if I look at that, I'm at almost 1.1 billion. That's one measure. Another measure is what are unique nodes on the internet, right? Not quite the same as FQDN. This is a little more pervasive. And this is what's growing geometrically, right? So we have all these things coming online. So the challenge that nobody really looks at too much yet is we're going to 50 billion nodes in the next 5 years with an addressing system that's designed for 3.7. And that's not including any kind of overhead or networking or anything like that. That's just raw numbers. So that's a challenge. All right, so looking at this mathematically, and again, I'll not spend a lot of time about this, but I thought this was kind of interesting. When we look at addressing systems, there's been lots of addressing systems, right? There's been lots of phone numbering systems, there's been lots of other protocols besides IP, there's been lots of attempts at how do I create an addressing system and use it, and when does it no longer work or no longer serve me because it's too inefficient, right? So if you look at this RFC, somebody wrote this and spent a lot of time thinking about what makes sense in an addressing system. You know, how much can I get out of it, right? Because I might have 3.7 billion addresses, but I can't actually use all of them. There has to be some overhead for networking, for moving stuff around, for transit, for things like that. So the number, actually, if you look at, and this is a good read, if you look at all the systems, they came up with a system where you basically do the log of the how many nodes you have versus the theoretical capacity. And that creates what's called the HD ratio. And typically, well, before IPv4, you'd never want to go over 87% because it just gets too painful. So what's interesting is we're actually at 94. And I don't think anybody will be surprised by this, right? I mean, obviously, if we're doing cascading NAT, then we know the system is pretty strained. But again, I just throw this out there because one thing that I like people to think about is when we're choosing to stay with IPv4, nobody talks about what are the costs, right? Because every decision has a cost. And if we're using a system that's completely inefficient and not designed for what it's doing, there's a cost with that, which means we're choosing to allocate our time and money to make this work. Which, now, I'm not questioning that today, but as we keep going, right, and I'm gonna show you some of the costs, you have to start asking yourself, is that really where I want to put my time and money, or would I rather put it somewhere else? Okay, so oversubscription, right? So we're long past this. I mean, this is old news, that we don't have enough addresses. Right now we have about 14.5 billion unique nodes on the internet. So we're oversubscribed by about 4 to 1. So we have to have NAT. In fact, one layer of NAT is not enough. We have to have 2 layers of NAT, you know, and maybe 3. So that's just a given. That's old news. I'm not going to, you know, spend any more time on that. But there are some sacrifices. Because we have to have that, we can no longer have unique addresses. We can't have topological location, or not unique, and registration is difficult. Right? So things like security are a major challenge, right? A big problem with the internet, security is tough because I can't uniquely identify people, things fluctuate all the time. So it creates a lot of interesting challenges. The other interesting challenge it creates is when I have these multiple layers of NAT, it makes it much more challenging to have an advanced application. So, if you look at deploying CGN to keep stretching IPv4, what's interesting is, and again, I don't want to turn this into a network presentation, but just at a high level, all the ISPs that are doing or have done CGN, they've all reached the same conclusion. This is not a good technology. It creates a lot of problems, it costs a lot of money to support, and the best that we can hope for when we deploy CGN as a carrier is we're only slightly degrading the user experience. So if I'm an ISP and I'm deploying this to stretch out IPv4 so I can keep servicing customers, it costs me a lot of money to deploy it, it costs me a lot of money to support it, I have to potentially buy more IP addresses on the open market, and the users don't like it, right? And how much more are you gonna pay for degraded service? Right? You see the problem with that business model? So again, there's a cost problem with this in the long term. All right, so this is something that I don't think I've ever seen covered, unless it's covered in development sessions. So I just wanted to mention this. So most of the costs are known. On the infrastructure side, you know, there's hundreds of presentations talking about all the problems with CGN, so I'm not going to beat that to death. But what I don't see people talk about is, in order to make all of our modern applications work with these layers of NAT, we have to have frameworks. And these frameworks are extremely complex, right? Has anybody looked at WebRTC? So that's something that's gaining a lot of popularity to try and facilitate interactive communication, two-way video, things like that. But if you actually look at that spec, it's really complex, because we have to support going through all these layers of NAT, which is actually surprisingly difficult. So we have 3 general frameworks that the IETF came up with: stun, turn, and ice. And these are basically frameworks or kind of a whole set of standards that I can use to basically make my interactive application work through NAT. So interactive being audio, like SIP, right? So when I make a voice call, almost for sure it's SIP, right? The old TDM stuff is going away. So I know, I can tell you AT&T's goal is to kill it by 2020. I think the European Union is similar, right? Where it's going to be no more TDM, it will all be IP based, because there's no reason to keep TDM around, right? So SIP is an interactive application. It requires an incredibly complex framework to work through NAT. Video, same thing. Video, very complex. Any kind of a gaming system. And gaming isn't just for fun, for like, you know, World of Warcraft and stuff like that. Actually, it's a huge area for training, right? People have discovered that if you make training interesting, then people like to do it more and actually do it. So all of these things are required, and the other big problem is that there isn't really, there's no silver bullet. So let's say I'm creating a new application and I need to support NAT. It's not like I can just get like the stun framework or the turn framework or the ICE framework and use it. It's just it's almost like a development language, right? It's a set of standards, but you have to make it work for your application. So if you go and look at SIP or all the other protocols, each one has its own variant. It's constantly updated, constantly new cases, new standards. So all of this, there's no value add here, right? The only benefit is this lets our applications work through net. And we're talking about thousands of pages that's constantly updated. There's whole companies that all they do is help you make this work, right? So I mean, that's where we're at. So I'm not saying it's good or it's bad. It's just that this needs to be factored in our decision to keep IPv4 around, because this is the price we're paying. All right, so I'm going to kind of skip through this, right? So pretty much everybody's doing it, and this is what we have to do to make it work, right? We have to make sure that addressing has not been unique for a long time, so you can't use addressing, and you have to make sure your logging includes 5-tuple, right? Source and destination address and port in the protocol, and it has to be timestamped with something like NTP, because that constantly rolls over, right? So you're doing all this. I guess the only thing that I'll mention here is it does surprise me that in my consulting with customers, I still see a lot of people that in their security or in their application, they still assume that addressing is unique. And they'll tell me, well, I'm not going to IPv6. Okay, that's fine, but addresses aren't unique anymore. CGN is pervasive. It's all over the place. Not just in the US, all the countries that it's being rolled out. So how are you dealing with that? Well, I don't want to deal with IPv6. Okay, that's great. How are you dealing with addresses aren't unique, right? So again, regardless of what you do, these problems with IPv4 still exist and have to be addressed. Okay, so the other thing too is, I always get this comment is, can we just keep it around for 10 years or forever? So if we just constrain ourselves to the traditional view, right? So PCs, laptops, tablets, servers, smartphones, basically all your human interaction devices that were made to deal with people. If we just, because that's really all most people talk about, if that's all we talk about, we can probably stretch it out for at least another 5+ years. And I think that's the focus, right? And you could argue that, but I think it's at least possible. So, in terms of this, there are some challenges that I want to talk through. All right, so before I move forward, I'm kind of curious with this. How far? Question?
Well, actually, I think there's a problem with that in that, I mean, people aren't gonna just settle for the devices you mentioned, because like people gonna want their smart TVs and their Blu-ray players and all that so that they can watch their Netflix or whatever as well, so.
That's true. So let me come back to that, because I'm actually gonna talk about CES, which is along that line. So this is just out for my curiosity, because I still hear a lot of skepticism, is I'm always curious when people tell me that I'm not going to do IPv6, how far do you think we can stretch IPv4? And there isn't a right answer. This is just curious. So like I said, right now we're at about 14.5 billion unique nodes on the internet, an addressing system designed for 3.7 billion nodes. So how many people think we can get it to 10-to-1? So with 37 billion nodes on the internet, we're still going to make IPv4 work. I think it's probably doable. By the way, how long do you think it is until we get to 37 billion nodes? Anyone want to guess?
14.5 now.
3 years?
Yeah, probably three or 4 years. Yeah.
Yeah, it's like 2.5 times what we have now.
Okay. What about, anybody think we can get to 100 billion or 100 times? Nobody? I'll bet there's somebody who really thinks that we can.
I think we can.
All right, so the reason I go through this is,
Painful too, you could.
yeah, I actually wonder how far I could stretch it, but the reason I go through this is what's missing from most conversations is what's called the Internet of Things. So remember, I said that when everybody's thinking about IPv6, they're thinking of traditional devices, right? Devices that I, as a person, use. But that's really the minority of the internet, right? Or it will be shortly. So where all the action is in basically what's called M2M, or machine to machine. So these are devices like microcontrollers, sensors, actuators, things that monitor the environment and either record what's going on or possibly take action, right? And these are everywhere. And what's happening is this is getting deployed all over the place. And right now, if I look at all those device categories, not all of them are networked, although a high percentage of them are. What's happening though is by 2020, the integration costs are getting so cheap that by 2020, it'll just be ubiquitous. So every sensor, every actuator, every microcontroller, CPU, everything is just gonna have built-in networking. Because it'll be so cheap to do it, it'll just be automatic. Which means that all of this stuff can potentially come online.
Yeah, but those can run IPv6 while other devices run IPv4.
That's true. Let me come back to that. It's an excellent point. So this is I don't know how many people here deal outside of traditional IT stuff. So I'm not going to assume anybody has a background. So just to give you some perspective, if we look at something like microcontrollers, right now we're shipping almost 20 billion units globally, new units per year, right? And that's increasing exponentially. So that's net new, right? If we look at sensors and actuators, we see a similar story. And there's other types too. So these are net new devices that are becoming uniform or universally networked that are basically just continuously being added.
Where are you getting your numbers?
I can give you a link. It's
Yeah.
basically like it's a VAR. It specializes in, I can't remember, ICIR or something like that. But it's pretty. If you Google it, there's a lot of them. Okay, so those are easy. So this one is challenging those numbers, right? If you Google those numbers, I guarantee you they're easy to find. But this is from Stanford University, and they're basically saying we don't believe those numbers because if you go to this red part over here, this growth of sensors and actuators was totally unexpected. Because if you look at the projections like this, what's this based on?
Past history. Yeah.
That's right, it's based on past history and it's based on what the analysts can see now. But what's the problem with that?
It's not gonna work.
Nobody knows.
Yeah, right? You can't see how things are gonna develop. You can't see new products, new areas, emerging markets. So what Stanford is saying is they're totally missing the bus, and in less than 10 years, we're gonna have over 1 trillion sensors online. Right? And they're saying if you go into the 2030s, we're gonna approach 100 trillion sensors online. And they're not alone, right? If you look across the board, Bosch, HP, Intel, Texas Instruments, Cisco, GE, all these companies think like this is it. All the consulting firms, Gartner, McKinsey, they all think that this is the future, right? So what's interesting is, and this is going back to that, give me 1 second and I'll answer your question, is what's interesting is if you look at IPv4, right, I think most people are thinking, yeah, the number of devices is maybe going to increase like 20 or 30 or 40% a year. But the problem is that's just looking at traditional devices. That's not factoring in this. So this is, I guess what I want to present here tonight is basically IPv4 is not going to survive this. So this is what's going to force a change. Question?
Right, so yeah, there are a lot of sensors, a lot of things coming out. I mean, the lawnmower, automated snow blower, what have you. You know, but all of those things are going to be behind, you know, the home network. So it's not that they're all going to be exposed to the internet. They're all going to be sort of intraneted.
That's true for a lot of things, like especially if I say consumer category. But
From a security perspective, you gotta hide all that stuff.
well, I don't. Security is an excellent topic, but I want to keep us somewhat focused just because of time. Let me come back to that. But I do agree for consumer type stuff, you could make a pretty good case that a lot of that's going to be behind a gateway. I don't care.
Right.
But everything I'm going to talk about is mostly outside the consumer space. So
What types of examples of, we're talking traffic lights and all that stuff?
So like this.
Okay, you're gonna get to it.
Yeah. Okay, so so before I get to that, I just want to talk real quickly. So when I look at IoT or the Internet of Things, this is much different from the traditional network devices or the human interface devices, right? If I look at a laptop or a tablet, they have lots of memory, they have lots of processing power, they have relatively speaking lots of battery, lots of capacity. If I look at IoT type things, they don't. It's the opposite. We're back to tiny amounts of memory, tiny amounts of storage, tiny amounts of power, unreliable, only on every once in a while. So it's a totally different device type. So in order to make this type of device work, we have some much different requirements. So the most important thing is it must be very, very low power, right? Because we're looking at deploying these things in the field, we want them to last for years, so that battery's got to last a long time. It has to support a lossy or basically an unreliable network. You cannot assume the network's going to be reliable or that it's going to be on all the time. And it has to be simple. It cannot be a complex device. All the rollouts that people have done with these kinds of networks where they've had gateways, all the companies have said the same thing, doesn't work. It's got to be end-to-end. Just because in terms of complexity, scale, supporting upgrades, maintenance, it just doesn't work. So what's interesting is if you look at IPv4, it completely does not work, right? NAT is very chatty, takes a lot of battery power. Traditional TCP/IP does horrible with lossy networks. It's not designed for that at all, and it's very complex. So if you look in this space, nobody is seriously looking at IPv4. It's off the table. So now IPv6 is not that great either, but there's a special type of IPv6 called 6LoWPAN, or now it's being called 6Low for short, and this is basically designed to meet these constraints. So there's a whole part of the IETF and the IEEE that are focused on supporting these low power lossy networks. And these are where all the standards are converging. And so with 6LoWPAN, we can meet this low power and lossy network setup, and IPv6 has built-in auto configuration, so that allows us to support this. So I don't want to spend a lot of time on this, but I just want to point it out to the best of my knowledge, and I would love for somebody to give me a counterpoint on this, but to the best of my knowledge, all the standards bodies, all the major companies, all the major companies and vendors, all the major analyst firms, all the universities, everybody is in universal agreement that IPv6 and 6LoWPAN are the future. I can't find any counterpoints. So if you can find a counterpoint, I'd actually be curious to hear it, but as far as I can see, and it's kind of funny because you have to look for this. It's not the headline, it's kind of buried in the article, but if you look at all of these areas, they're all converged on the same thing. All right, so in terms of practical examples of, okay, how are people using this stuff? So one concrete example I can give you is energy, is the smart grid. So I can tell you that one of the major, I'm not sure about both, but one of the providers in Michigan, their entire metering infrastructure is IPv6 only, right? And it's based on this 6LoWPAN technology. So that's widely deployed all over the US. Building automation is coming. I know a lot of people that are looking at that. I'm going to talk a little bit more about that later. Transportation. So this was front and center at the Consumer Electronics Show. There were several demonstrations of autonomous vehicles. So I think somebody had an autonomous vehicle go from LA to Vegas. I can tell you that Ford is working with U of M right now, and there's all kinds of autonomous vehicles driving around Ann Arbor. And Google says that by 2017, they will have products on the street. That might be a little optimistic. More conservative elements will tell you 2020.
GM said they're offering something, 2016,
Oh.
2017.
There you go, so then maybe we will hit it. So, but autonomous vehicles are very real, right? There's a lot of stuff going on. So in order for this to work, for these connected vehicles to work, you'll have to have all kinds of communications capabilities. And all of this is pushing towards IPv6 just because of the scale. There's a whole bunch more examples, I don't wanna go through all of them. Let me talk a little bit about the Consumer Electronics Show. So one thing I can tell you with IoT is it's definitely still an emerging area. So it's not mature. So it was very interesting to watch CES this year because IoT is everywhere. I mean, everybody is abuzz with it. But in terms of, if you look, what they're gonna say is, yeah, everything's getting a sensor, an actuator, a microcontroller, everything's gonna have the option to get online and do data, but we don't quite have it fully baked. Right, so I wanna be candid, this is not here today. Right, everybody's focused on this, it's coming, but it's still emerging. Right, so, you know, and this is the tough part. When is it gonna be mainstream? You know, probably a couple of years, but I don't know. I can't give an exact time. It's something that you need to watch. Wearables, especially in healthcare, there was a lot of stuff at CES. Self-driving cars, robots, drones, a lot of this stuff on the grid works automatically, no human intervention. So that all requires massive address space. All right. These are just some more examples. I don't think I'm going to go through too many of these on time.
You're in Detroit with manufacturing intelligence.
So there's lots of stuff. So connected vehicles is probably the one you hear the most about. One other thing I'll mention here are the smart buildings. So I think, if I remember correctly, 40% of the grid of our national electric grid is used to power buildings. It's a huge amount. And basically, if you look at businesses too, a huge percentage of their budget is basically pumped into maintaining buildings, just HVAC, lighting, basic stuff. And it's all totally inefficient. So if you look, like I read a report by Gartner, they were talking about this. If you look at doing some kind of facilities energy management system, 40% is not that hard. So I mean, it's a significant amount of money. Again, this is typically something outside of IT, so something you have to look for, but I can also tell you that a lot of companies that I'm working with are pretty far down this road. So that's another thing. And then, well, I'll stop there. All right, so one thing I want to point out is, and this is a bit of a disconnect, typically when you talk about networking, IP, IPv6, stuff like that, you're typically talking to IT people, right? Those are, and that's who's usually governing that, and that's where I work too. However, if you look at all the people that are working in IoT, they're all outside of IT. So it kind of creates an interesting situation, right? Like, for example, when I'm working at companies and they're looking at facilities management, IT has no idea. And then, like, I actually introduce the two, and they'll be like, oh yeah, this needs IPv6, that's not a problem, right? And they almost fall over. So there's typically no communication between the groups. Consumers, I'm gonna leave out, but the other one is engineering. So a lot of, if you look, for example, automotive sector, right? So you have all this stuff going on with connected vehicles, autonomous vehicles, advanced driver assistance systems, all these new technologies. A lot of this stuff requires advanced networking. But again, these are really smart people, they're doing stuff on their own. So not necessarily working with IT. So that kind of creates an interesting situation where IT is basically, will say, you know, nobody's asking for it, so we don't need it. Right, so I don't know if you've seen this one. And I mean, I'm guilty of this too. So, and if you ask IT, this is what they're gonna parrot back. And this is everybody. I don't think anybody would disagree with this, right? I'm not gonna deploy IPv6 because there's no value and nobody's asking for it, I don't want it. Now, if you read all the analyst reports that will say this is a low value thing, there's always a little asterisk that says, unless you're doing IoT. but nobody, again, you have to look for it, right? It's the fine print. All right, so you have all these different groups, facilities, engineering, operations, that are looking at these new technologies that are leveraging this. But here's the problem. If I'm a plant manager, do I care about TCP/IP or IPv6? I don't care about that, right? I care about, are my cars making it off the line into the showroom, right? As far as the details, you know, whatever. So it creates an interesting situation because the people that are using these technologies are generally not networking people. They don't care about it, and so they don't even think to ask it. You know, I want all this new stuff. I don't care what it runs. I just care that it works. But because they don't realize that there's that underlying need, then we have a bit of a problem. So we have groups that want to deploy these technologies. The group that supports the network, though, doesn't hear an explicit call out for it and thinks it's not needed. All right, so I went back in history because I always heard this, that you know, we've always had TCP/IP forever, never anything else. I didn't think that was true, but I actually went and checked. So the internet actually, when it was created, it ran something called NCP, which was a totally different protocol. And TCP/IP came along later. And I always heard this thing about there's no flag day for IPv6. I was curious about that. That actually came from NCP. So DCA, which is now DISA, which is basically the part of the DoD, they basically said that, okay, for our applications, we like TCP, we're going to switch to that. They really didn't care about the network part, they just thought it was better for their applications. That was what drove it. And so they decided, okay, we're not going to do multi-protocol, we're just going to do TCP/IP, so everybody on the internet has to switch. And you have until January 1983, and we're turning NCP off, and that's it. And that's how it got transitioned. But one thing I found that was interesting is, if you actually look back at the history of this, even though there were a whole bunch of limitations with NCP, and everybody agreed that it was a logical progression to move to TCP/IP because it had a, you know, it's basically better, more functional, the users did not want to do it. They were totally against it. They were irritated. You know, why are you making this change? This isn't a priority. And basically, only because the DCA forced it is why it happened. So today, though, that's not going to work, right? Because the internet's distributed. So one thing for me is, in the past year, I've changed a little bit from, my focus is more on architecture and less on engineering. And so as part of that, I have to deal more with kind of processes and looking out into the future than I did before. And so I've been reading this blog by Simon Wardley, great guy, and he talks, his focus is on IT strategy. That's all he talks about. He's not interested in, or he's not into the technical stuff, he's a pure strategist. And he talks about how things evolve. So one thing that I found kind of interesting is when he talked about cloud computing, he basically went back to the electric grid. And I guess a long time ago, before we had a national electric grid, companies would actually generate their own electricity. And it took a long time before people were finally like, okay, I trust the grid, I'm gonna plug into the grid and I'm not gonna have my own generator. And he basically compares that to cloud computing. He says we're undergoing a similar transformation, you know, in his opinion, we're undergoing a similar transformation. And what he talks about is, as things evolve, from somebody creates this new idea, and then it evolves into something that's custom built, and then pretty soon it's a standardized product, people rent it, and then eventually it becomes a utility service. So he says that things tend to evolve. And what happens is, as things evolve, the people that created all these products, and compute is a perfect example of this. If we look at all the traditional compute companies, they create all these great products, they have everything set up, they're making a lot of money, and they have been fighting cloud tooth and nail, right? So what's hilarious is, people have seen this coming for, I think a guy wrote a book about cloud computing in 1966, he pointed out, right? So it's been known for a long time this is gonna happen, and who's the person that basically came in and capitalized on cloud computing? An online book reseller, right? How can you believe that? An online book, a small online book reseller has basically cornered the market. And all the behemoths are quaking in their boots that they can catch up. And some people think they can. right? So what basically what he says in this blog is, when the companies create their products, they get comfortable. You know, I'm making a lot of money, I have a whole ecosystem, I don't want to change, right? So what he says is an outsider has to come in that has no investment in the current products, right? Somebody like Amazon, and say, you know what, I don't care about the status quo, you know, I'm moving to the utility model. And I think this is kind of where we're at with IPv6 today. We're stuck in this space right here, because we're all comfortable with TCP/IP. It's everywhere, it's in all our products, it's in our code. I mean, even if you think about accessing something on your network or at home, do you think of the DNS address, or do you know all the IPv4 addresses by heart? Or how many programmers still hard code IPv4 addresses, right? I'm guilty of it too, because we know it, right? It's so ingrained. And so the hard thing is, how do we get past this inertia barrier? Because as you can see, if we look at where we're going in terms of stuff on the network, right? This, I mean, you know, the timing might be a little off, but I mean, if we're going to 100 trillion devices on the internet, I mean, there is no way that can work with IPv4. I mean, there's just no way. And this is not that far off. So this is the hard thing, is making that jump. All right, so I'm just going to make this confession right now, right? So this is usually the most popular question I get is, you know, when we're looking at deploying IPv6, when do I really need it? So that said, now that we've gone through this, can anybody see with waiting until somebody actually, what about the plan? Let's say nobody's asking me for IPv6, right? Now, if I'm a small company, I can probably get away with that. But if I'm a sizable company, right? Like if I'm a Fortune 1000 company, what's the risk if I don't do anything until somebody comes and asks me? How long is it going to take me to roll it out? Yeah, that's a very good question, right? So this is a little tough, right? Because you can see it coming, but the problem is nobody can really tell you when. You know, I wish I could say by 2017 you have to have it roll out. But what I can do is I can give you some data points, right? And I'd actually be very interested in some candid feedback on this, because anything I can give people to make it clear or to help you see what's coming, I'm interested in. So there's lots of common questions. You have a question?
Yeah, talking about manufacturing plant for that
Sure.
type of thing, Profinet, how does all this impact things like that?
So what's, excellent question. What's changing in terms of all the old proprietary standards is those are all going to be swept away and replaced by TCP/IP, right? So if you look at, you know, like Bosch and Honeywell and GE and all the people that deal with your traditional controls type networking and automation, that's slowly evolving to TCP/IP. Now, in terms of, you know, where exactly they're at and how fast it's going to happen, it depends on the manufacturer. I mean, you know, my off-the-cuff assessment of manufacturing stuff is, I think it's still a few years out.
We've got a lot of timing concerns and durability concerns. That's why they're using some of these older networks. So
Yeah, because right when I you know, if I pay, you know, for example, I think my wife is from Windsor, so she told me that Chrysler is putting $2 billion to renovate one of their plants, right? So if you're pumping $2 billion for one plant, that better last for a long time. So I can definitely appreciate that. If I'm going to spend all the money on the line and the new equipment, I got to have confidence that that's going to last for decades. So it's evolving.
you know, it's the manufacturers, and when I was designing plants, they were, you know, they had their own network controls guys. And
Yeah, Modbus and all, it's all proprietary.
So.
Yeah, so that basically all the proprietary stuff is fading away for the same reason that TCP/IP took over the internet. because if I can get away from all that proprietary stuff and move everything to TCP/IP, then it just makes it easy to standardize and make things more modular. So that's gradually happening, but you know, from my research, I think that's still a couple of years out. I think what we're gonna see first is the facilities energy management, because that's a no-brainer, right? If I can save even 10%, for any sizable company, if I can save even 10% on my power costs or my HVAC costs, it's a no-brainer. I can pay for it really fast. So we're gonna see a lot of that, and we're gonna see a lot of connected and autonomous vehicles, drones, robots, stuff like that. That's what's ready for prime time.
Well, from a facilities perspective, what I saw in the industry was they're moving towards service-oriented models, where there's a company that they say, we're gonna pay X number of dollars, and if you can save, you know, you manage the whole thing. So they're bringing in all their equipment and doing their whole, so it's service-oriented. There's companies that are providing facilities energy management as a service.
Sure.
So-
Yeah, absolutely. If we can outsource it, why do it ourselves?
So they would naturally ride on top of whatever network was in place.
So I think that, so cloud has been a little slow with IPv6, but I did see something from the Red Hat VP in charge of their OpenStack unit, that he thinks this year it's gonna take off. Because if I'm a cloud, let's look at the cellular industry, right, because that's what I know really well. If I look at AT&T and Sprint, and I don't know this from being an employee, I just know this from outside knowledge, but if I look at how their cellular networks work, I have all these overlapping pockets, and I have this super elaborate system to manage it. Now, if I control the entire infrastructure like a cell company does, I can get away with that. But if I'm a cloud provider and I have thousands of customers, and each one of those customers is gonna have overlapping address space, I mean, it just doesn't scale. It's gonna kill my cost model. And so the more we move to outsourcing stuff and the more we move things into the cloud, we have to move to an addressing system where everybody can be unique, just because otherwise it kills me on management. Because the management costs to manage all the overlapping address spaces are really prohibitive. Like, I don't know if you had to deal with ANX at all. If you look at the automotive stuff with trying to make that work, it's a nightmare.
Just within the plants, they
But even within the plant, right? So I have to have some kind of a network path into that plant. But then for that back-end provider, right, he's got all the various customers. If all those customers have overlapping address space, it makes it a nightmare for him to manage it.
obviously, but they're providing it as a service, so that there are different types of savings coming on, and they have the expertise in managing all the devices, so they're getting them connected to devices however the devices are sitting in the plant.
Yeah,
They don't have control.
To a point you don't care, but, right, at the end of the day, for them to stay in business, they have to charge you cost plus, right? So the more you can help lower their costs, the more you can create a market type establishment where you have competition between different providers, then you can lower the costs overall. But that,
Obviously, it's just there's different business models that are pushing in different axes.
yeah. So,
That's the night talking about that.
Well, I could talk about a lot of stuff. I have a lot of questions. So my first question really has to do with, so you're gonna have these devices that move around, right? Is IPv6 capable of handling mobility like that? Devices moving from one subnet to another, one connection point to another?
so there is a mobile IPv4 and IPv6, but outside of the cellular industry, nobody uses it. So maybe someday, but that's not something that's currently in any host operating system. And I can tell you that Linux, Microsoft, and Apple have no interest in it. So I don't expect that to change in the near future, unfortunately. So from a host perspective, no. From a network perspective, there are some solutions, but they're pretty complex, and that's kind of a whole topic. So not a great answer. Does that?
That's kind of the answer I would expect.
Okay.
Is it mine? I get the impression that IPv6 gives each and every device a unique address. Is that correct?
Mm-hmm. That's the idea.
What his
Persistent
question about
address?
the mobile use really doesn't matter.
Well, so here's where mobility is interesting, right? So, if cell phones aren't a good example because it's built in. If I take my laptop, right, and let's say I have an SSH connection. I mean, this is kind of an overly technical example, but let's say I have an SSH connection to some kind of a system, and I'm running an application on it, right? So if I go from the wireless network to an LTE network and then plug into an Ethernet network, it certainly would be nice if my connection could just roam across all those connections and I wouldn't just have to keep disconnecting and reconnecting. So there is a lot of value in mobility, but like I said, the operating systems vendors are not interested in doing it. So there are solutions, but not from an operating system perspective. Let me table that one because it's a very interesting area, but that's really a whole night's topic, talking about mobility.
Next year's day.
So what I wanted to show, so when most people look at IPv6, they're kind of familiar with that Google page, but there's a problem with the Google page. When I look at the Google IPv6 statistics page, does anybody know what it's showing me? That's showing me global adoption. But really, do I really care about global adoption? I mean, there are billions of people that are never going to buy my products or services, right? So I don't really care globally. I really care per market, right? So if I look just at the US, I don't know if you guys have seen this. This is where we're at in the US. So at the beginning of 2013, we were at about 6.25% penetration. And at the end of 2014, there tends to be a spike at the end of the year. It went up to like 14.5. It's actually come back down to 13.5. But we doubled, right? So going back to these questions real quick, there tend to be lots of questions, right? There's so many ways you can look at IPv6, but probably the most useful one that's on the next page is, does it work end to end? So if I'm sitting at my house, or I'm sitting on my cell phone or my tablet, or I'm sitting at Starbucks, from my access device, can I go all the way to an IPv6 site or service, right? Because in order for me to do that, everything else has to work. And what this is showing is, what percentage of users have that capability, right? What's my penetration? So right now, we're at about 13.5 to 14%. So that's not a ton.
That seems pretty good.
That's
But,
good.
but yeah, it's probably more than a lot of people think, right? It's not a few percentage points, it's significant. And if we look at the next 3 years, so this is curve fitting, right? So take it with a grain of salt, but it is based on data from the past 3 years. So this is Google's data going almost back to the beginning of 2012, and this is basically, the blue line is how we've ramped up, right? And if we do curve fitting, that's basically our projected adoption. And I think that's actually, I've played with the data a bunch of different ways. This is a fairly accurate projection. So even in terms of ramp up, I mean, you know, that's 3 years out. So 3 years is a long period of time, but
How is this affecting the TCP applications? Since everything's running on TCP.
It's still mostly the same, but there are some differences. Because if you look at it from a socket level,
Right.
you have to do the pseudo header, right? So the pseudo header is going to be different for IPv6 than for IPv4. So there are some changes.
So everybody's gonna have to go and change all their
Yeah.
TCP applications.
Well, it depends. So I'll confess, I'm not a developer.
Big problem.
So if I use Java and I use like the generic socket call, I'm fine. Right? So if I use a more modern language and I use the abstractions, and I know that's also true in Windows, although I don't know what the exact calls are. If I use like a native socket call, like a low-level call, then yeah, then I'm talking code. I'm talking updated code. So it depends. But I will tell you, and let me come back to that because I have a slide. But it's a non-trivial effort. So I just wanted to point this out. In terms of critical mass, 10% is the minimum, 15% is moderate, conservatively you'd say 20%. So however you define critical mass, if you define it on the more aggressive side, we're already there. Even if you define it conservatively, that's maybe 6 months off tops. So right now, we have over 34 million users in the US that have IPv6 access. So from a product point of view, right, so one thing that I got a kick out of is, I'm, working in companies, and like I said, typically IT has a negative reaction to IPv6, and I can appreciate that because they have too many things to do, right, and it's one more thing. But last couple of months, I'm sitting there and somebody's saying, nobody ever asked for this, it's a waste of time, blah, 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 blah. And an engineer walks in and says, we just bought a really expensive modeling application, and it's IPv6 only. And I want to deploy it tomorrow, and that's not a problem, right? And I had to try really hard not to laugh. But, right, that's where it's going. I've also seen several instances of where people put stuff out for bid or for RFP for cloud services, where somebody would come back, and these aren't small companies, these are some of the big vendors, and they'd say, yes, we have a great solution, we have a great price, but you have to connect to us using IPv6. So right now, those are edge cases, but they're becoming more and more frequent. Question?
Yeah, from a traditional IT perspective, if we accept the fact that sooner or later this is coming, what are there things that we can or should be doing now to make sure that we are?
Give me a few minutes, and I will answer that.
Before you get to that, I've got a question.
Sure.
You're saying there's 34 million some people in the US using it.
Yep, just in the US.
That's actually using.
So is this people at home with their Blu-ray player, or is this, I mean, like, how many people here are using IPv6?
I said I
How-
can't.
Pretty much what I was expecting.
Yeah.
How, well,
Right.
I guess,
But-
how many people make a point of checking which protocol you're using?
Well, the thing is, like, if you get a Comcast, if you have Comcast internet at home, right, the Comcast will do IPv6. But how many, you get that at home, you put a wireless access point
That's
plugged
true.
in your router,
If it
right?
doesn't support
And then you do your,
V6.
and then you do your Blu-ray player, your Apple TV, or whatever you've got. None of that's IPv6, is it?
Some of it is. So I can tell you, my Blu-ray player does support IPv6, you have to turn it on. My printer supports IPv6, you have to turn it on.
It's not enabled by default.
No.
Right, so
So-
all these people have equipment that could do it, but don't do it. I'm just curious who these 34 million people are.
Actually, so.
I have a hunch that
if-
most of them don't know they're doing it.
No. Well, I mean, it's, you know what, so, my standard joke with networking when I'm teaching a network class, right, is whenever I have a problem at home, my wife or my kids will say the internet's broken, right? Is the internet really broken? But I mean, it's just kind of an illustration that nobody cares if they're using IPv4, IPv6, or IPX, or whatever, right? Can I get to Facebook? That's all that matters. As far as how I get to Facebook, I could care less. Does it work? So most people could care less. So we got to get to the point where it just works.
Interesting note about Facebook, internally, they're all IPv6.
Yeah, yep.
So, isn't the biggest problem today with adoption is the fact that there is no ROI or perceived ROI on it? So you're gonna spend 10, 20, 100 grand, maybe $500,000 and not get anything for that other than maybe the ability to link to some application that's IPv6 only.
So look at it like this. I'll tell you right now, you're not gonna like this answer, but look at it like this. What's your ROI for having electricity or heating? It's infrastructure, right? There's, in and of itself, it's worthless. I mean, its only value is it's a platform that you need to build other things on. Now, the hard part is deploying it is non-trivial. So you don't want to do too much, right? Because I agree
That's
with
the
you.
whole
You
point,
don't.
it's gonna cost you equipment and
That's right.
time to deploy
it won't-
but you're not gonna get anything
it won't-
immediately out of it.
Yeah.
You're not gonna get it faster.
Well,
It's
it's a
not
little-
like
okay.
going, spending.
Well, actually-
It's a little bit like Y2K, right? Think about it. During the 90s,
Yeah.
people didn't want to invest in Y2K because they didn't see the problem, right? But there was a hard problem. We knew we had to do it by December 31st, 1999. We had to, right?
There's no flag
Here,
like this,
there's
though.
no,
Yeah.
there's no point.
Deadlines, there's no deadlines.
There's been deadlines, but we've blown past them.
Basically,
We were gonna run out in the 90s.
IPv6 is
idea.
asymptotic, right? So with IPv6, I have an asymptotic function.
Yeah.
And if I look at that function, it's basically my pain threshold, right? I'm never gonna get, there's always a way to make it work.
Sure.
But the question is, how much pain are we willing to put up with in terms of all the costs with applications and overhead and all the other stuff until we switch? And to be honest, I don't know. Let me get through these real quick. So this is just showing, if I look at different market segments, right? We've mainly been talking about enterprise. But if I look at telecom, if I look at all my tier 1 providers, they are fully deployed. So this is interesting because, let me tell you, working for one, tier 1 ISPs are ultra conservative. I mean, they're like the federal government, right? They won't spend a penny, believe me, they will not spend a penny if they're not convinced that they have to do it. And look, they're 100% deployed, right? So this is like AT&T, Level 3, Cogent, NTT, Verizon, Sprint, all those companies.
What do you
right?
mean by 100% fully deployed?
Internally, right?
In terms of their core, well, user access services, maybe not. But in terms of their core and all their business-facing stuff, it's done. So in terms, this is transit. So in other words, can they route traffic through? All of them can, end to end. Now, if we look really, and if you look at transit providers, are basically, this is really the internet, right? Probably the top 100, or maybe the top 300. I mean, that's basically all the major companies. Maybe, top 1,000. Now you're getting into kind of the small players. Most people tend to deal with the top 1 or 200. So yeah, there's 11,000 transit providers, but those, the bulk of the internet is probably the top 1 or 200. And if we look at all up to the top 1,000, we're pretty far along. So when you hear that IPv6 is early adoption, that's true in the enterprise space, but that's not true as a whole, right? So just one thing I wanted to show. All right, I wanted to briefly mention this because people still talk about it. I don't think this matters anymore. Okay, I throw it up here. So we have two. If you don't understand the RIR system, and I don't want to go into it because, like I said, I don't think it's that interesting. Aaron is the one we use for the U.S. and Canada, and they're down to I think roughly 7 million addresses. They're going to run out this year. This is saying April. It might stretch out into May or June, but for sure it's going to happen this year. Do I think it's real? I mean, you'll see some press about it. Do I think it really matters? No, I don't think so. I think really with exhaustion, I think this is a distraction. This is not what's going to push us to IPv6. What's going to push us is when I'm deploying trillions of devices on my network, that's what's going to force me. Because it's going to be so painful to try and make that work with IPv4, that's what's going to push me. But because everybody talks about it, I at least wanted to throw it in there. Okay, so in terms of, so let me go through this fast because I don't want to, we got about 15 minutes left. In terms of, do I need it? Okay, so I do this for a living, right? So I'm biased, so take it with a grain of salt. But here's what I tell people that ask me. You need to closely monitor IoT. So I can tell you that most verticals, including in Michigan, have a lot of IoT activities going on. I mean, like for example, if I look at the automotive, IoT initiatives are basically touted by the CEOs of all the automotive companies in Michigan. I mean, they are key strategic initiatives. Autonomous and connected vehicles, I mean, Ford and GM see that as one of the top things. So these are huge. So you definitely, and remember that disconnect about the people driving those initiatives are outside of IT. So you need to, I'm not saying you should do it, but you definitely have to monitor those initiatives and be clear about what does that mean for me. If my company is doing these strategic things, what do I have to support? The other big thing is mobility. So I have four major wireless carriers in the U.S. Verizon, AT&T, Sprint, and T-Mobile. Verizon is fully deployed. If I have a Verizon phone, unless it's ancient, or I have a Verizon hotspot, it's dual stack. It's been like that way for years. If I look at Verizon's traffic, I think almost 2/3 of it is running IPv6. So the majority of Verizon's wireless traffic is IPv6. So even, for example, I know a lot of the automotive companies, they get their cellular devices and their hotspots from Verizon. So they have IPv6. They might not have intended to do it, but when I'm taking that hotspot and putting my laptop on, unless I disabled it, I'm on an IPv6 network. So that's one thing you want to watch. T-Mobile, the other interesting thing with them, T-Mobile setup is IPv6 only. So there's no IPv4. They get around that using something called 464XLAT. It basically, this is really interesting. So with 464XLAT, I pretend like I have an IPv4 address to make things like Skype work. I translate it to IPv6, it gets to a gateway, and then I translate it back to IPv4. So it can cause some real interesting problems if you have to troubleshoot it. But this, and T-Mobile's not the only one. There's 2 other major carriers and more that are looking at deploying something like this. So the other thing is, in terms of, if I choose not to support IPv6, more and more, for my workers that are using, hotspots or cellular connectivity or something like that, I might be stuck troubleshooting 464XLAT. So keep that in mind. Okay, if I look at all the major ISPs, they are all far down the path. A lot of them are done. Comcast, for example, is fully deployed, or they're, like I said, they're well down the path. Because we don't have enough addresses, all the major carriers that I know of are using CGN, which means that, so now, you decide how strong this argument is, because there's a lot of different opinions, so I'll just give you the scenario. The scenario is, if you don't choose to deploy IPv6, then basically a lot of your customers are going through CGN, right? Now, if I'm a carrier and my customer, you're not my customer, and I have lots of customers going to you, and I'm doing CGN, how much do I care about your content? What do you think? Yeah, I don't care. So, if the user has problems accessing your application because their carrier is using CGN, who do you think they're going to blame? That's right, they're going to blame I can tell you from first-hand experience, they're going to blame the content provider. And I don't know if you've ever called up a carrier support, because I have to deal with them too. Good luck. If you crack that one, let me know. As Jim mentioned, Silicon Valley, all the Silicon Valley companies are IPv6 deployed. Google, Microsoft, Oracle, Facebook. Facebook's IPv6 only, right? So all the major tech companies long ago have gone IPv6. I was actually talking to a manager in the automotive industry the other day, and he was like, with IPv6, what's Toyota doing? And you know what I said? I said, you know what? I wouldn't worry so much about Toyota. I think your competition is Google and Apple. Right? Look at Google's time frame for rolling out an autonomous vehicle. They're one of the most aggressive companies in terms of testing the technology, in terms of coming up with all the maps, in terms of rolling it out. So this potentially can change the landscape. So there's a lot of major companies that are really investing heavily in trying to capitalize on this. So again, I'm not saying you should do it, just be aware of what's going on. Right? All I'm offering is the truth. That's it. Okay, in terms of what to do, so I would highly recommend a lab. A lot of companies have labs. If you have no lab and no lab budget, you can use your house. That actually works pretty well because it's mainly, no joke, a lot of it's just learning the basics, right? So I would strongly recommend, though, playing around before you go into production, right? Anybody remember this? You do not want to deploy, because IPv6 is not, I don't think I would call it hard for somebody that has a networking background, but you're not gonna take a 1-week class and be an expert, right? I don't know if anybody remembers learning TCP/IP. Who learned TCP/IP in a couple days or a week? Yeah. So this is the same, right? It's gonna give yourself some time. So basic goals, right? We want to be able to connect to the IPv6 internet. We want to be able to allow access from it. We want to be able to publish applications to it, and we want to allow our users to get to it. So, connectivity, I'll go through this quick. First thing you need to do, if you're looking at this, is you need to talk to your ISP. So, I will tell you, and I'm sorry to say, even working for a major ISP, that you're going to have to put your patient hat on for this. Because even my own company, I have talked to people that have told me, and keep in mind, right, I do IPv6 for a living, and I've talked to people in my own company that were like, nobody does that. Why would you want to do that? And I'm just like, what a freaking kidding. So I'll tell you, even recently, doing some deployments, even working with tier 1 ISPs, if I wasn't under contract, I'd make fun of them on Nanog, but even tier 1 ISPs have people that don't know what they're doing. So, and in fairness, right, if I look at IPv6, if 15% of people have it, that means 85% don't. So, you know, all right, I can appreciate that. So, there are a lot of knowledgeable people, but you're not going to get to them on your first try. You're going to have to work alone. I wish I had better news, but that's how it is. So, if, you know, unless you have a really, really small ISP, if you have any sizable company, they should have it. As far as I know, all the major companies have it. If you have a really small company and they don't have it, I'd look at switching, because there's so many, I mean, seriously, there are so many ISPs and there's so many deals. I mean, you could probably switch, get IPv6 and find cheaper service. I mean, there's no reason in 2015 to settle for that. So I think that should just be a given. If they talk about a surcharge, same thing, I would switch. I mean, it should just be free. Other than, you know, they might charge you a one-time provisioning fee, but that's it. There's no service premium, it's just a given. It's a standard part of internet access.
So, just hitting on your point that you're not gonna get the good support right away, I'm looking at the AT&T site and I'm trying to figure out, well, what do I need to do? One of the things is updating the firmware on my 2-wire device. And it has this statement, it says, please do not call customer care requesting for the firmware update sooner or for the exact date, as we cannot provide this information.
Yeah, I'm not surprised. Yeah, it's, it'll definitely test your patience, unfortunately. I mean, that'll get better over time, especially at the small office consumer level. Like, I like Comcast. There's a lot of talented people at Comcast. You know, I've had a Comcast connection for a long time, and their support. I mean, I even have a business class connection, and it's awful. I mean, they have no clue. So, you know, unfortunately, that's
Just try to cancel that.
yeah. Okay, and then the last thing is, when you're getting it, you want native service. So, you know, I guess if you have somewhere that's kind of in a remote location, you might be stuck with tunnel service, where basically they're tunneling it over IPv4. In general, though, you know, in any significant market area, I mean, this should be a given. It should be easy to get. It should not be a big deal. If you get it through MPLS, they're gonna, you know, every carrier has their own name for the technologies. But if they're doing 6B or 6VPE, you don't have to understand what it is. But if they say they're doing one of those, that's fine too. So, but you basically want native or MPLS access. You don't want anything else.
MPLS is IPv6, uses IPv6.
No, actually, MPLS is an IPv4 technology, but you don't care, because MPLS is what the service provider uses to basically share their network with customers and create the illusion that every customer has their own network. So that's the service provider's problem. But from the customer's point of view, it looks like native IPv6 access. And there's no, it's not, unlike other tunneling technologies, there's no degradation. It works fine. So MPLS is kind of big. Because the reason you generally don't want tunneled is if I have native access, it's direct. If I have tunnel access, I might go over here and come back. It's suboptimal. So with MPLS, there's one path, so you don't have to worry about that. So it's kind of a whole other talk, but in the MPLS case, it's fine. In any other case, probably not. All right, so I have a basic checklist here. Like I said, I mean, you can Google this stuff. I'm not going to go through it. I mean, if you have a single connection, it's pretty straightforward. You know, you put in your address. It should usually be a 64. There are exceptions for the site length. Your default route. The one thing that you have to be careful of is, from an access point of view, make sure you understand all your security features and controls, and you have parity for v6. Don't just turn it on, right? Remember, v4 and v6 are shifts in the night. So if I just turn on v6, then my device is totally wide open. So Telnet, SSH, web management, SNMP, anything else, syslog, it's all no controls unless I enable them. So be careful with that one. So this is relatively straightforward, as long as you're careful with making sure you understand all the features. If you have, if you're multi-homed, or in other words, you have multiple network connections, I would strongly advise you to get some help. So you don't have to do like a super expensive engagement, but you should at least talk to somebody and have them review your configs. Because like I said, I mean, if I'm talking to tier ones and they're messing it up, then somebody with no experience, I think that would be pretty tough to get everything perfect on the first try. So at least have somebody do a look over or something like that. All right, equipment. Okay, so this goes back to the costs. So once you look at bringing it in order to bring it in, my border equipment, unless that's managed by my ISP, if that's the case, then you don't care. But if you manage your equipment that connects you to your ISP, it might already support it. If you've gotten it within the last few years, you should be fine. If it's older than that, you might need an upgrade. A lot of times you just need a software upgrade, it's not a big deal. It's not a big deal as long as it's under support contract. If it's not under support contract or you have to buy anything, then there's a cost. A lot of times the cost is not bad. So then it's just a simple question. If you have the budget for it, get it. If you don't, that's the biggest reason to do it now and not wait. Because if you do it ahead of time and it's not in the budget, no problem. You plan for next year and you put it in next year's budget, right? That way you don't have to do a fire drill. So that's one advantage of doing it ahead of time.
That's great for corporate, but home user, I mean, they want to soak you. I'm looking and they're saying if you got these 2 routers, then you got to spend $100 in order to upgrade.
Yeah, it's all over the map, but
That's a one-time cost.
yeah.
Well, what I've seen is the cheap access points and stuff. Buy
Yeah, you
Best
can't
Buy.
upgrade. Yeah, it's basically a throwaway device.
Yeah,
So you have to buy it how you want it.
Well, the problem is if you got a certain carrier, you are stuck with a certain type of gateway.
So let me keep going here just so I can finish real quick.
Yeah, I know, sorry.
All right, no problem. No, next one is remote access. So if you set up your router, which is generally pretty straightforward, the next step is remote access. So in other words, if I'm at home or if I'm partnering with another company, I want them to be able to access me. Now, I don't know if any of you do any kind of networking, but I've already run into quite a few cases on like a small office, home office type connection where you can no longer get a public address. So you'll basically order, like for example, if you get a DSL circuit or some kind of broadband, they'll say, you're gonna use our gateway and we don't offer public addresses and you're gonna like it. And if you don't like it, then I literally have told them, if you don't like it, go buy service from somebody else. So if you're in a situation like that and you can get IPv6, then you don't care. Because with VPN, the VPN itself can be IPv6, but all the user traffic inside can be IPv4. So in other words, you don't care, right? The part that deals with the user and connects to your network is still IPv4, is still beautiful, still transparent. But you're using IPv6 to solve the lack of address space problem, and just the VPN itself is IPv6. So this is great if you're dealing with places where you need remote access or management access, but you can't get a public address.
So I used to have static IPs, IP4s, and I eliminated that. I think I probably don't need it, but I do want to be able to access my devices that are at home from remote locations. Can I do that with IPv6? Do I have to go to AT&T and purchase something from them, or?
I mean, it just depends on, so like AT&T Cellular doesn't have V6 yet, but if you have a Verizon Cellular, then yes. If you have T-Mobile Cellular,
Okay,
yes.
so
It
I'm
just
saying
depends on,
like laptop to home server.
depends on where you're connecting from. Some places have IPv6, but like it's only 10 to 15%, right? So most don't. So if you're connecting from a location that has native V6 access or tunnel, then yes. But if not, no. But let me come back to that because I'm gonna.
Okay, so what I'm stuck on is my device at home, my server at home. That has a unique IPv6 address?
Yes.
Okay.
If you get IPv6, it's going to be unique.
and persistent,
It depends.
It should be,
Depends on the
but
provider.
some providers don't.
Depends on the provider. But there's ways to deal with that, just like before, right? You can do dynamic DNS registration and stuff like that. So yeah, some of them, they usually all can do it. Some of them might charge you more. Okay. Publishing. So this is the next one, right? If I want to make my application accessible, So in terms of making your application accessible, the operating systems are no problem. Those have supported for a long time. Most of your major platforms and databases support it. I can't think of too many exceptions unless you're using something that's pretty old. But the work is, let's say I have some kind of an application and I'm migrating it to v6. Things like all my database fields, my user input forms, address parsing routines, stuff like that, all that's going to need to be revisited. So it's typically not trivial. So it's not like you're going to go and redo all your applications. There's no way. It's what's your business case. So the way you deal with that is there's three options. So just in the interest of time, generally you want to do the last one. So NAT 6.4, it sounds easy, but there's something called MTU mismatch, which I'm not going to, it's somewhat involved, but basically it's very hard to troubleshoot and you're going to run into it somewhat frequently. So I would say that makes this technology undesirable. Reverse proxy is pretty straightforward, but the problem is performance. Whenever you use a proxy, you're going to have scaling and performance limitations. So, you know, for a small setup, it's fine. For a massive setup, you're going to be disappointed with the performance. Most sizable companies use a load balancer, right? So if you have a load balancer, any recent load balancer is going to support this. So basically what happens is the load balancer publishes an IPv6 address, the user connects to that IPv6 address, and then the load balancer, I mean, forgive me, I'm going to be kind of sloppy with my terminology, but the load balancer translates it to IPv4 to the application.
And the library is closing.
Because of the way it does this,
at 9
this is
o'clock.
the most transparent
connections will begin
method,
to
right?
shut
Most
down 10
applications
minutes
work
before
really well with
closing.
this, and this is kind of the easy button. The nice thing about this is you can make your applications accessible with relatively minimal, with a minimal amount of work, right? So it gives you time. So now you're not going through CGN, you're in complete control of the connection, you're not going through cascading NAT, and you can make stuff available, right? You don't have to convert right away, because that's really where the cost is. The network part is easy. The application part is a lot, is a huge undertaking.
Dual stack too, right?
That's true, but if you dual stack, your application has to be able to deal with it. And that requires a lot of testing, and some can't. A lot of applications.
No, I'm talking about to the load balancer. Your public address,
yep.
you could have an IPv4
Exactly.
and an IPv6 public address.
Exactly.
And the load balancer would turn it all into IPv4 and send it to the application.
Yeah, excellent point. So you're basically just adding v6. You're not losing your v4 capabilities.
Good for transition.
Yeah, excellent transition. And then finally, this is for your users to get out. Dual stacking is ideal. That unless you have a small network, that's a lot of work. Proxy can be pretty good here. If I have a limited number of users, I can get a commercial solution or an open source solution. That works pretty well. And then there is tunneling. I'm not going to get into that. That's really better for labs, but it's a possibility. ISOTAP is built into Windows. And then finally, VPN. So the VPN one, just coming back to the point earlier, if you have something at home, for example, and you're at a Starbucks and they don't have IPv6, there's a lot of service providers that will give you a cheap VPN connection where you can get dual stack. And then using that VPN connection, then you can go anywhere on the IPv6 internet. So you could purchase a third-party service, or you could set this up on your own to allow people to get IPv6 access. So I went through this fast, but I mean, like I said, I mean, technically, all this stuff you can Google. I mean, there's nothing to it. I mean, all the major products have pretty extensive IPv6 guides to be able to figure it out. The main thing is understanding what to watch for so you don't get blindsided and thinking about what you want to enable. So hopefully, at a high level, that helps. Any other questions?
That's cool stuff.
Can I jump to a more technical,
Sure.
advanced type of?
Sure.
Virtual networking.
Mhm.
So if I want to set up devices on my home network that make use of like a, VMware or something like that, is that something that an AT&T would support, or, can you do that, or is there some kind of issues with,
I mean, all the hypervisors support IPv6, so there's, well, OpenStack, it's more recent, but if you look at like VMware, if you look at Hyper-V, if you look at KVM, and what's the other one? I say VirtualBox. Not Virtual, what's the other major one? not VirtualBox, more for like enterprise level.
What's Microsoft?
Microsoft's Hyper-V, KVM, but Citrix Zen.
VMware? Oh, Zen.
So all of those supported, right? I mean, except Hyper-V is kind of an exception, but with the rest of them, they're just emulating a switch. So they're emulating layer 2. So for the most part, they don't care. They're oblivious, right? Because IPv6 is in layer 3.
Other than their administrative interface.
That's true, but I mean, there are some quirks, but they all support it. So, I mean, it's basically like any other network. See, I mean, unless, do you have something specific, or, I mean, I can tell you, I have VMware at home, and I'm running it with IPv6, and.
Yeah, but the carrier, the Comcast or whoever, AT&T, they're not gonna give you, they're not gonna route a whole network to your network. They're gonna give you an endpoint.
It depends, so.
Unless it's business.
Yeah, so for a business class, you get a /56, which is 256 networks. For consumer class, I thought for consumer class, they were doing 56 too.
Wow.
But it depends on the provider, some only give you a /64, so.
You said 56 networks or 56 devices?
So a /50, okay, so in IPv6, in general, my subnet mask or my CIDR length is always gonna be a /64. It's gonna be fixed. So if I get a /56 from my carrier, that means that I have 8 bits to play with for networking, or 256 networks. Right, if I get a slash.
Nodes, not
Not nodes. Each network can handle 18 quintillion nodes, right? Basically unlimited.
So, that's just the first half of the.
Yeah, so the
128.
the second half is reserved for your host, and it's basically, that's,
Okay.
see, and a lot of people have a hard time with this. Oh, you know, I'm gonna have 18 quintillion possible nodes, but what's the point of V6? The point of V6 is simplicity, right? Here's a great question for networking people. How big should a wireless subnet be in IPv4?
Unlimited.
Say as much as you can
Well,
afford.
in IPv4 though, right? In IPv4, we can't have unlimited. We have to, the fundamental tenet of IPv4 is conservation. So what's the right size for a wireless network in IPv4?
C
Is it
class?
500, 1,000, 2,000? But this is a trick question. The real problem is, who cares? Why should I think about it? All networks should be fixed, right? Again, if I'm going to trillions of devices, I can't think about how big my frickin' subnet size is. That's a waste of time, right? It should be standardized. It's always this, done, next, right? So and that's hard. It's hard to get used to that because I'm giving up that control. Actually, I read an interesting article for autonomous vehicles. So there's a prediction that a lot of people are gonna have trouble with autonomous vehicles, which I can see. That's a little scary, getting in a car with no steering wheel and no control. So one of the executives from the auto industry found something that said, when people get into a vehicle where they can't interact with the driver, they would give them a map. And once they got used to reading the map, they'd be comfortable. And then he revealed, you know when they came up with that system? 1720. Because in the systems in 1720, they would not let the passengers talk to the driver. They got in and that was it. They were stuck. So they gave them a map. Right? So it's just kind of a mentality shift. So there's going to be a lot of changes over the next 5 or 10 years. But one thing for sure in networking, it's got to be simple and automatic. Not just in networking, everything, right? All technology. You've got to make it simpler, more straightforward, more autonomous, more manageable. Any other questions?
Yeah, we're about ready to wrap
Yeah.
up. Well, that was excellent.
Thank you very much.